All right, so going to look at slope fields, which is basically when we're going to look at a graphical representation of all possible solutions. Okay? Daniel, don't talk, buddy. All right, so if we're looking at this one here, then as Julieta said, what we need to do is separate our variables. So we get 2y dy equals x plus 3 dx. Once I've separated the variables, huh?
It's not like plugging.
We need to clear it.
No, not yet. That's the initial condition, which we're going to use to find c later. So once I've done this, I need to integrate both sides. So this side is going to be 2y squared over 2, or just y squared. This side over here is going to be x squared over 2 plus 3x plus c. Okay. Then if I'm trying to find c, now I plug in my initial condition of 1 and 2. So 2 squared is going to be 4. 1 squared is 1, so 1/2 plus 3 plus c. So to figure out c, we have to combine these and put them over here. 3 plus 1/2 is 3.5. 4 minus 3.5, 1/2. So c is going to be equal to 1/2. So then I go back and I write out my equation. Y squared equals x squared over 2 plus 3x plus 1/2. But I'm not finding y squared. I need to find y, right? So I'm going to square root both sides.
Can't you just square it?
Yeah. And so I'm going to get, y equals plus or minus the square root of x squared over 2 plus 3x plus 1/2. But we know that one of those probably isn't going to work, so I need to check it. How do I check it?
We look to see if it's within the domain. Can you cancel the
Kind of. It's no.
It can't give
'Cause
us like
it's-
negative 1 is equal to
You have to
1.
have, it has to be something like this. X plus 3 squared, square rooted to cancel. So I can't cancel this.
So we just plug in the initial condition. So
Yeah.
2 equals
2 is going to be equal to, therefore right off the bat we know which one's not going to work. The positive,
negative.
the negative. Because if this is 2, I need this to be positive, and the square root has to be positive. So we need to get rid of this negative one. Perfect. So that's our solution. Not so bad, right? That's what we did last class. Good. Go part-time, Pauline. All right, so now we're going to do the slope fields. So this is a pictorial representation of every possible solution. Okay? So remember, a differential equation is the first derivative of a function, or like f prime or dy dx, or all the different ways that we've said it. So there's an infinite number of solutions to this differential equation. Why is there an infinite number of solutions? What is the thing that appears when we integrate? C, the constant, which ends up like making a whole bunch of different versions of like or possibilities, right?
So C is that slope.
No, C is not the slope. No. So here, like if we did this, we would end up with the integral of dy equals x minus 1 integral dx, right? That's going to give us y equals x squared over 2 minus x plus c. This is the part that means that we get a whole bunch. So unless we know this, unless we know c, there are an infinite number of possible solutions. Right? Because if we change C, we get a new solution. Change it again, we get another solution. So there's an infinite number of them. So we're going to try and like capture that idea of multiple solutions. Just to mess with you. No, not actually. We are going to do it, but not to mess with you. Okay, so now we're going to do a little bit of writing because those of you writing the AP exam are going to appreciate this. All right, so on the AP exam, or in my class, so you still need to know this anyway, I will expect that you are able to do the following. You don't have to necessarily write this part, but you're going to want to write these steps. The next part is what you want to write, okay? So I'm going to expect that you can sketch a slope field given a differential equation dy dx. I'm also going to expect that given a slope field, you can draw a particular solution. So you're going to be able to like map out one of those possible solutions. You're going to be able to match a slope field to a given differential equation. And you're going to be able to match a slope field to a hang on, match a slope to a solution
Demórate bastante.
of a differential equation. So those are the four things that we need to be able to do. I'll wait and let you copy them. They may not make sense yet. That's okay. They will make sense later. Just not right now. Right now, Manuel, why'd you close the window? You lie.
But it's better. It's really
No, just por ejemplo.
Okay, fine. Who do we think is the slowest writer?
Part-time for me.
Part-time Paulina. Okay, when part-time Paulina finishes, we move on.
Mr. Pratt,
Yep.
did you read Project Hail Mary?
I have not.
You have to read it.
I've
And then you
heard.
have to watch the movie.
I've
You
heard.
have to do it in that order.
Oof.
Like, it's not,
Okay.
but it's like a really short book.
Is it?
It's like 400 pages.
Well, when I get my surgery and I can't speak, I'll make sure to read.
Or you can read it now.
What's
Okay.
it?
But I'm still reading other books.
But it's so great. It's so
Not
sweet. And you have to
something with
watch
my
it.
face. Like my jaw. They're gonna break my jaw.
Oh my god, you're gonna be
My
so
upper-
skinny.
My upper, like jaw is like this, and then my bottom one is like twice as wide. So the problem is my top teeth fit inside my bottom.
You have an overbite.
No, like not like just the front ones. Like I mean the entire jaw.
O sea, el arco es súper
Slips
chiquito.
inside.
El de
Yeah,
yo tenía eso.
Anyway, it sucks.
Yes.
So,
I have an underbite.
all right, part-time Paulina, you done? Come on, we got to move on when you're done.
Paulina, yo también.
Part-time Paulina, let's go.
Oh my god.
And then we get to draw pictures together.
That sounds like so.
Yeah, it'll be fun. Yay, part-time Paulina's done.
No.
But part-time Paulina's done.
No.
We decided part-time Paulina was the slowest, and she's done. She's not so part-time. All right, guys. We're going to take this differential equation below, and we're going to compute the slope for every single point. No.
Yes.
Okay? Then we're going to make a small mark that will approximate said slope. When we fill in the whole grid, we end up getting a slope field. Amazing. Ready? Let's do it. What? Too bad. All right, so let's go through these, okay? Is y going to be important in this particular differential equation? No, because there's no y. So I'm just going to be looking at x. So we're going to do when x is -2, then y prime is going to be equal to -2 minus 1 or 3. -3, sorry. So when I go to -2, I need to draw a slope that is roughly -3. So it should be like roughly down to there is what I'm going to be pointing at. So there we go. One slope, done.
That made no sense at all.
Why? Y prime dy dx is going to be equal to -3 when x is -2.
Why?
Because I plugged in -2.
Why would you choose -2?
Because I'm at -2. What about if I'm at -2 here? Is it change? Nope. What about here? Well, it should be -3. So here's the way I do it. Look. Okay? If it's supposed to be -3, I'd go from here, over 1, down 3. So I should try to kind of connect it as if I was connecting it to that line. That's how I usually do it. So this one would connect down to here.
So that is
This
all-
one should connect to there. And so that's what it's going to be. They should all look roughly like that, roughly at -3. Amazing, right?
I made them sparkly, but it's
Nah. I mean, you can always do it with a ruler. And then it's like real easy.
And then at x equals -1, the slope is -2.
Exactly. -1 minus 1 equals -2. So
it's slightly less slanted.
now we go all the way down this row, and we go slightly less slanted. Exactly. Because now we're trying to connect it down to there. Amazing. All right. What about if x is 0? Exactly. So now it's even easier. Okay. What about if x is equal to 1?
0.
Exactly.
So it's a yes.
Okay. It should start to look like and make sense now. And then our last one is
It's
to
gonna
go
be 1.
x equals 2. 2 minus 1 gives us +1 this time. So now when we draw these ones, we need to draw them all as a slope of +1.
So basically, it's anywhere that curve could be.
Exactly. So what does this mean? It means that we don't know why, but we still can tell the shape of the graph now, right? It's clearly a quadratic, which makes sense. It would be like x squared minus x, right? If we integrate that. So it should be a quadratic, but we just don't know where it is here. So what this does is this lets us kind of figure out, oh, it could look like this, right? And so when I said, like, one of the things I want you to do is given a slope field, what was it? Draw a particular solution. Let's draw a particular solution. Does that matter which one I draw then?
No.
Nope. So I could like go from here and I could just say, oh, it's going to come down. And then that's a really terrible line. And then it's going to get steeper. And then it's going to get even steeper. And so it just looks something like this. Right? The 11th. Last month. May, dear. May. May. Sorry, that was mean. I was mean. Will you forgive me? That kind of makes sense? Did I have to draw that particular solution? Could have drawn it anywhere, right? I could also go and be like, no, you know what? I'm going to draw it. Whoops, that's terrible. Oh my gosh, I cannot draw it quickly. This is much easier on paper. I could have drawn it there, right? Okay. So let's do another one, shall we? Oh, we're waiting a second. Part-time Pauline is still doing stuff. Loronio, get out your notes. Good. Get out a pencil. Face me. Thank you. All right. So this one's going to be a little bit trickier, right? Because when I look at this one, it's not always going to be the same. The only time that I can look at this and say, I know exactly when this will always be the same is if x equals y, right? Because if I have x minus y, that means every time that x equals y, I'm going to end up with 0. So I can go ahead and put in all of those ones, right? Does that make sense to everybody? Like if it's x minus y, if it's x minus y, if x equals y, it's 0.
Sure.
That doesn't make sense.
But you could, technically, you could fill all of the points.
And that's what we're going to do now.
But why those?
Well, because if x minus y is equal to my derivative, then if x and y are the same number, it's 0.
But like why those?
Porque negativo 2,
Because this is 1, 1, 2, 2, 0, 0, -1, -1, -2, -2, right? The rest of them, guys, you're just going to plug in. So, like, let's do an easy one. Let's do this. This is the point 1, 0. Well, 1 minus 0 is going to be a slope of what? 1. Okay, now, on purpose, to help you identify patterns, I'm going to do this one. Okay? If this is the point 2, 1, it would be 2 minus 1. What's my slope? 1. So what do you think this one's going to be?
1.
Probably 1. Let's do it to make sure for your sakes. So I'm going to get... So to confirm we're right, it's going to be 0 minus negative 1, which is, of course, 1. So yes, so basically we're following this kind of a pattern for this one, right? So that means that all 3 of these are probably going to be the same as well. So this one would be 2 minus 0. Well, that's a slope of 2. This one here would be 1 minus negative 1. Well, that's also 2. And then this one here would be 0 minus negative 2. Well, that's also 2. So those ones are all a slope of 2. These ones here should be the same as well then, right? So 2 minus negative 1, 3. So make it even steeper. And then 2 minus negative 2 is going to be 4. So we make that one like really steep. Okay. Now, hopefully this pattern is going to continue here, but let's check a couple to make sure. So let's do this one. I have 2 minus 3. What's that going to be? 2 minus 3. Negative 1. This is probably going to be negative 1 as well, but let's make sure. So 1 minus 2. Negative 1. So all of these ones now we can say, okay, these are all just going to be a slope of negative 1.
And then this one is 2, and then the next one is
Probably going to be 2. Yeah. So 1 minus 3, negative 2. So it's going to be steeper. 0 minus 2, negative 2. So these just get steeper. Probably going to be negative 3. 0 minus 3. Yep. Negative 3.
and then 4,
Exactly. And then 4.
and then 5.
And then our last one is 5.
Then this is-
Kind of making some sense?
So it's like elbow shaped.
Yeah, exactly. So if we were to draw it, it's easiest to kind of do it up here. So it's going to look sort of like that. And then as we come down further, it's going to go like this and then start to go back up. Right? So these would be 2 particular solutions. So when I ask you to draw one, most likely I'll say like, draw a particular solution or draw a particular solution that goes through 0, 1 or something. Okay, I might tell you where to go. But usually I'll just let you draw it, and you can draw it. Okay? Does that kind of make sense, guys?
Yes.
Yeah, show up on time, girl. All right. Cool. I'm waiting. We're going to do the next one.
Like a little bit.
I know, it's not bad. It's honestly, slope fields are not that bad. The hard part is like the visualization. As soon as you can figure out like how to visualize, then it's pretty easy. If you have a hard time with that, it's hard. But if you can sort of visualize, okay, like what's the pattern recognition? How do these slopes look? Then it becomes pretty easy. All right, we got to move on. So we've got a slope field, and we're going to figure out which of these is true, and we're going to explain our reasoning. Okay, guys, anytime we do this, we should always start. Oops, do it in blue. We should always start.
By drawing.
I'm going to say by using zeros. The reason, okay, is like we can look at here like what made dy dx equals 0. Because like for instance, it's a 0 here and a 0 here. Right? This is a 0, this is a 0. They both got slopes that are 0. So let's analyze, say, this guy here. Right? This one happens whenever x is negative 1. Does it matter what y is? No. So we know that regardless of what y is, as long as x is negative 1, it needs to be 0. So if we put this in, if I put negative 1 for x, does y change it? Yes. So it can't be that one. If I put in, why? Because if I put in, say, y equals 3, it would be negative 3. if I put in, I don't know, like 4, then it would be -4. If I put in -5, it would be +5. Because x is always going to be -1 on this line.
So -1 minus -5.
No, these are multiplied. So it would be -1 times, and there's no way to get that to be 0 unless y is 0. Well, that would mean that it would only be 0 here, but it's not. It's 0 everywhere. So that's why we got to keep going to kind of figure out what it could be. So these two, I'm going to say that we should probably factor them to help us. So this is the same, actually maybe I'll just say equals, as being y x minus 1. And this one is the same as y x plus 1. This one is the same as x y plus 1. Okay, so now it's easier to take a look at what we're doing, right? So remember, if x is -1, it's got to be 0. Which of these does that satisfy?
B.
This one? C. Yeah, so we can get rid of these two, right? Because if I put in -1 here, I'm going to get that it's -2. So y, it's like it depends on what y is then. Whereas here, if I put in -1, doesn't matter what y is, it's times 0. And here, it's going to be -1 times, yeah, it matters what y is. So it's got to be C. But let's check E. Could be E. If I look at E and I put in -1, what happens?
0
It's
squared.
0. It's 0 cubed, which is still 0. So it could be E. So we've at least narrowed it down to those two. Do you see how I did that by using the 0? It will be easier using 0 than anything else. I mean, you can pick any point you want, but it's easiest by using 0. Okay? So the other 0 is going to happen here, right? So that one happens when y is 0 and we don't care what x is. Is that true for E? Is it true for C? Yes, because we get 0 times who cares. So it has to be this one. Okay? Now to explain our reasoning, I mean, we use the zeros, right? That's how we do it. Like in the case of this one, y equals 0 gives y prime of 0. And x equals 0, or x equals -1, sorry, gives y prime equals 0. So we used our slopes of 0 to figure it out. Awesome.
Wait, x equals -1
Gives y equals 0, or y prime equals 0, sorry. Like we're basically identifying these two, because these are the ones that are easiest. Right? Now that won't always be the case, but when you get one like that, it's always going to be easier to just use that point. So even like on this one up here, the fact that these are always 0, it's when x equals y. Okay? Alrighty. So let's try one from 2004. Just after I graduated. I mean, I took Math 35, which in Canada is like, it would be like BC.
Oh, Canada.
Exactly.
Can you sing that?
Yes, I know how to sing that.
Okay, so sing it.
I'm not going to right now.
No, right now.
Okay. Consider the differential equation. No. So we got this differential equation. Do también. On the axis provided, sketch a slope field for the given differential equation of the 12 points indicated. All right, so
I love how they started with x minus y and now whatever.
no, but it's not that hard. Look at it. It's actually not that bad. So it right here, if x is 0, does it matter what y is?
No.
Nope. So all of these ones are going to just be zeros. What value of y will make it 0? 2. So all of the times where y is 2 will also be zeros.
But where is
Because 2 minus 2. So when y is 2, all of these ones, independent of x, has to be 0. Now the other ones, we got to plug them in. So for instance, this one is 1 and 3, right? So 1 to the power of 4, 1, times 3 minus 2. So 1 times 1. Nice and easy. Okay, then we just do the others. So let's try this. Let's do the other one here.
1 times 1.
So 1,
-2 is -1.
Negative
1 is -1.
exactly, right? Because we've got 1 times 1 minus 2, so 1 times -1.
And then 1 times 0 is just 0.
This one here? Not quite, because it's going to be 1 times 0 minus 2. So negative 2. Right? So what I'm doing is I'm plugging it into here. So x is 1, y is 0. I'd get 1 times negative 2. If you need to, do the work on the side, guys, like we did at the beginning.
We have the other, so it's
Right.
another quadratic. They're mirrored.
Yes. So then when we do this one here, we're going to get negative 1. Doesn't matter, because negative 1 to the power of 4 is 1. So it's just going to be 1 for all of those for our x's. So the y is what's going to be important. So it's 1 times 3 minus 2 is 1. So it goes up.
So it's not mirrored.
It's not.
But you told me it was mirrored.
I said, I might
You
have.
said, yeah. So I drew it mirrored.
Oh, sorry. That's why you got to actually do it, man. Sorry.
I'm not a man. Respect. Don't misgender me.
Oh my god. Sorry. Okay. So then 1 minus 2 would be negative 1. So this one here would be the same, right? Negative 1. And then this one here is going to be 1 times 0 minus 2, so negative 2. There's A. Done.
So it's like that little S looking thing.
Could be. What is this exactly? It's weird. It's a weird looking graph, right? Okay, so now we can do B. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. Ooh. So what does that mean? That means that we want dy dx,
No.
which is equal to x to the power of 4, y minus 2. We want this thing to be negative, which means that we would want 0, and then this thing here has to be less than 0. So x to the 4th, y minus 2. That should be a y. It looks like an x. My apologies. Okay? And then I can just solve that, right? How do I solve that?
I don't know.
First, we turn the x to the other side.
So we could, but it actually won't even matter because x to the power of 4, what's going to happen?
It's always positive.
Always positive, right? This is always positive.
So those are the only points at which it's negative or what?
So that means that the only part that matters is here. So really we're investigating 0 less than y minus 2. Huh? You're both saying it one of you's right. Yes. So I'm going to add 2, not negative 2 here, because we got to move it to the other side first. So it'd be 2 is less than y. Or greater than y. Y is less than 2. My bad. Okay, so y has to be less than 2. So it's going to happen everywhere. I guess we should maybe say. We could say dy dx will be less than 0 everywhere that y is less than 2. Not equal to, has to specifically be less. And we could, if we wanted to say, we could say regardless of x. Right? Because the x isn't going to matter because it's to the power of 4. Yeah? Good? All right, let's look at C. Find the particular solution, y equals f of x, to the given differential equation with the initial condition 0, 0. Well, now we can do something, right? Because
Plug in.
we can do what we were doing in the last topic. So we're just going to take our derivative, so dy dx equals x to the 4th y minus 2. And we have to start by separating our variables. So we're going to get dy over y minus 2 equals x to the 4th dx. Then I integrate both sides. Awkward. I don't have to do a use of. I could, but I can probably just identify this one. If it's over, like 1 over y, ln. So we're going to use natural logarithm of the absolute value of y minus 2 equals x to the 5th over 5 plus c. Amazing. I know.
And
All right,
what's
now,
ln of y minus
well, we don't know, but we do know the initial condition, so we're going to change x and y for 0. So we're going to do this at f of 0 equals 0 now, and we're going to get ln of the absolute value of -2 equals,
Why I care, I'm not taking it from
well then, we don't worry. All right, so this means that C,
Sir,
6.
what happened to x?
Well, it's 0, 0, right? So 0 to the 5th over 5 is 0. Just like the y is 0, so I just got rid of them both.
0 over 5.
Yep. So that's all we did. All right, now I'm going to write it out. So now I've got the ln of the absolute value of y minus 2 equals x to the 5th over 5 plus ln of 2. All right. So I need to raise this to the power of, like, e to the power of this so that I can get rid of everything. Okay. So e to the power of these things. E to the power of ln, great, cancels. Absolute value of y minus 2. Over here, I'm going to write it as two separate ones because it's going to be e to the power of x to the 5th over 5, and then times just 2, because it would be e to the ln of 2, right? Which is just 2. So I'm going to put the 2 in front. Do you remember how e to the ln, right? That's 2. Yeah, we're good with e to the ln of 2? Okay, good. Excellent. All right, so now I need to break this up into two different cases, right?
I have a question. It's plus 2 y multiplied with
Because if I have, this is all the exponent. So how do I get an addition in the exponent? By multiplying by the same base. So this is technically, like, that's the same as e to x to the 5th over 5 times e to the ln of 2. That would mean the same thing. Okay, so now I've got to do it where y minus 2 stays the same, 2e(x to the 5th over 5. Or we reverse all the signs, so it becomes 2 minus y equals 2e(x to the 5th over 5. And remember our initial condition, f of 0 equals 0. It has to pass that.
Too fast.
Ooh, sorry, I did kind of get fast there, didn't I? I got excited.
I didn't understand what you just did.
I just wrote down the two different cases. If it's an absolute value, they could be positive or they could be negative. So I have to take both cases into account.
but you just like
But you just changed it.
Yeah, so I reversed the signs. Yeah, I reversed the signs inside the absolute value. That's all. Easy.
but you did that.
Yeah,
Hard time, Paulina? Turn your brain on.
you know what you could do to turn our brains on? Sing "Oh Canada."
I'm not going to sing okay.
Sing "Oh Canada," please, for me.
Look, if you think it, I'm going to pause, for example, Neil will be engaged.
We're going to go ahead and plug in our initial condition instead. Guys, if I wasn't sick, I'd maybe consider it, but
No,
I'm
no,
pretty sure if I
put
tried to
on-
sing right now, I
I'll
would
put
just
on
cough.
the karaoke for you. Wait.
all right, so we're going to make x and y both 0. So this is going to be -2 equals 2. Clearly not. Right? Because e to the power of 0 is 1, so it's just 2.
Is there a possibility that none of them work?
Not in this class.
Oh my gosh.
No.
Why did I
All right, so this one's going to be 2 minus 0, which is 2, equals 2 e to the power of 0, which is 1. Hey, look, it works! Yay! This is my solution.
Do I have to prove that the second one works, or can I just be like the first one?
Yes. Check them both. All right, so then my answer, now I need to actually solve it, right? So it's 2 minus y equals 2e(x to the 5th over 5. And remember, we kind of learned that, like, fast trick on how to do this. Hey, do you need someone? Me? Someone else? Uh-oh. Yeah, you can go ahead. All right, so then here, I would just add the y to both sides and subtract the 2, right? So I'm going to add y to both sides, and then I'm going to subtract 2e(x to the 5th over 5. Normally, I wouldn't even write this, but let's write it so that we can practice. So I get 2 minus 2. Basically, we're just switching the positions of these two, right? Which means we're flipping the signs. So this is 2 minus 2e(x to the 5th over 5 equals y. And we're done. Incredible, right?
Okay, it's "Oh Canada" time.
Can I ask you a question? I don't understand that. Wait, can you go up?
Now it's from one when, like, much further. I think I might have even been done my undergrad by then. My first one. Okay, so why do you no? Like you could have asked me earlier. No. Ladonio, come on, buddy. Consider the differential equation. Blah. X cannot be 0. On the axis provided, sketch a slope field for the given differential equation at all 9 points indicated. Why does it say only 9? Because x can't be 0. So there shouldn't be anything here, right? Because if it was 0, it would be undefined. All right, let's do it. Let's start here. So when we are at y equals 0 and x is 1, we get negative 1 over 1. That's negative 1.
But there will be 9 points. Where?
The 9 points. And then this one, right? Oh, hang on. I did that wrong. I wrote that one. No, I did it right. Negative 1. God, I scared myself for a second. Now when I put in 2, no, it's worse. Now it's going to be 0 minus 1, negative 1, over 4. So it's got to be like 1/4. Negative 1/4.
No dio miedo.
No, that's only 1, 2, that's only like 3. It's like really flat. Huh? Oh. All right, let's do this one over here to finish up those ones where y is 0. Now we're going to get negative 1 over negative 1 squared, still just negative 1. Because when we square negative 1, it becomes positive. Perfect. Love it. All right, let's check out this one. 1, 1. 1 minus 1, 0. Amazing.
So all of the ones that are on y equals 1 are 0.
There you go. All the ones for y equals 1 are going to be 0. It's going to be 1 minus 0, 1 minus 1. All right, now we do this one, 1, 2. So this is going to be 2 minus 1, 1, over 1. So positive 1.
Our x is not equal to 0.
And now we're going to have 2 and 2. So 2 minus 1 is 1 over 4, 2 squared, right? So that one's going to be positive 1/4, which is like some really steep line. Or not steep, really shallow line, sorry. All right, then we're going to put in negative 1 for x, which isn't going to matter, it's just 1. So it's just going to be 2 minus 1, which is 1, over negative 1 squared, which is 1. Amazing, look at us go. And we also know, we might as well draw this in, if x can't be 0,
It's an asymptote.
there's an asymptote there. So we might as well draw that in, just to help us remember, okay?
Draw how
So if you were asked to
No,
draw
we
the line, how would you do it?
The line on this one?
Yes.
Well, it all depends, right? One particular solution could be that it, goes like this. Another one could be that it goes like this, right? On this side, ooh. So it would be like, you know what? I think this one is going to be, would it be like that? I think so. Or like that. Those would be my 4. All right. Now, 4 styles, I should say. All right. Where? Here? This is an asymptote. Oh, that's just the slope is horizontal. That's all. Find the particular solution, y equals f of x, to the differential equation using this initial condition. So it means solve it, right? So we're going to get dy over y minus 1 equals dx over x squared. Integrate both sides. We already did this left side. It's just the ln of the absolute value of y minus 1. This one is not ln. Remember, 1 over x squared is the same as x to the negative 2. So it's going to be x to the negative 1 divided by negative 1, so negative x to the negative 1. Or if you prefer, negative 1 over x. Okay? Now we can plug in our initial y what? So you add 1 to the exponent, which makes the negative 2 become negative 1, and then you divide by negative 1. But rather than showing this, I just wrote times negative 1 because it's the same. Okay? All right, now I'm going to plug in my initial condition where x is 2 and y is 0. So I'm going to get the absolute value of negative 1 equals negative 1 over 2. Because remember we said that negative x to the negative 1 is also negative 1 over x. Okay? And what is the absolute value of negative 1? What's the ln of 1?
1.
Close, but no.
0.
0. So this is going to be 0. Oh, I guess I should actually put the plus c, so we're solving for something. My bad. 0 equals negative 1/2 plus c, which means c is a half. Right? C is just going to be positive a half.
Sure.
All right, so then we can go back to our initial one there. So ln of the absolute value of y minus 1 equals negative 1 over x plus 1/2. And now I need to solve for y, which means I need to raise both of these to the power of e. I think I did this question with you earlier, didn't I? This feels really familiar to yesterday.
No, because you probably had the other class yesterday, but we have never done the.
No, but I didn't do 7.4 with them. I did 7.3. Anyway, that's okay. It's not a big deal. E to the power of ln will cancel. Absolute value of y minus 1. Oh, I think it was just similar. It wasn't the exact same way.
It was super.
And then this one would be e to the negative 1x times e to the 1/2. And I can simplify that side, so I am going to. So absolute value of y minus 1 equals the square root of e, right? That's e to the 1/2. To get rid of this negative, I'm going to put it on the bottom. And what is negative, like what is 1 over x? What is that really saying?
1 over x is.
Okay, if we were differentiating, but I'm just saying as an exponent, sorry.
To the negative 1.
So it means this, the xth root, right? Because like if it was 1/2, it's the square root. If it's 1/3, it's the cube root. So if it's to the 1 over x, it's the xth root. Does that make sense? Yeah? Okay. Now there's a reason I'm doing that. It's going to make our lives easier. So now we have to split this up and do our two different cases. So y minus 1 equals square root e over the xth root of e, or 1 minus y equals square root e over the xth root of e. And what's our initial condition? If you look up.
It's where x is not equal to 0. If f
Is
of
there-
2 equals 0.
There you go, f of 2 equals 0, yeah. So we're doing this at f of 2 equals 0. So we're going to make x2 and y0. So this one's going to be negative 1 equals square root e over the square root of e, right? Because if x is 2,
So
okay.
negative 1 is equal to 1.
So negative 1 doesn't equal 1. So we can put that all in and say nope. This one better work then. So this is going to be 1 minus 0 equals the square root of e over the square root of e, which of course works. And so that is going to be my solution. However, now I need to solve it, right? Can we do it all at once? Remember, if it's 1 minus y, we just switch these two places, right? So it's going to be 1 minus the square root of e over the xth root of e equals y. Right? We just add y to both sides, subtract the root e. Okay? It's the easiest way for us to do it. Excellent. Any questions before we move on to C? No?
No.
All right, let's take a look at C. For the particular solution y equals f of x described in part B, so the one we just found, find the limit as x approaches infinity of f of x. So we're going to do the limit as x approaches infinity of f of x, which we just found, and our f of x was 1 minus root e over the xth root of e, right? Or if you prefer, because it might be easier in this case, as x approaches infinity of 1 minus e to the 1/2 minus 1 over x. I think that's probably easier.
So which one do you
I would do this. Why do you think this is easier? What happens when I put 1 over infinity here?
1 over infinity.
The limit as
It's
x
just-
approaches infinity
it
of 1 over
cancels.
infinity. Kind of, it becomes 0, right? The limit as x approaches infinity of 1 over infinity is 0. So this is going to just be 1 minus e to the 1/2. Or 1 minus square root e.